Well, I'm wearing goggles. There's something that looks like a slinky next to me, and I believe a blowtorch is here as well. That means it must be time for some fun with physics with Mike Randall.
Good morning.
How are you today, sir?
I'm doing great.
Good. All right. Now we're talking about sound today, I believe.
Yeah, sound in particular because we have an upcoming event on campus. It's the Wisconsin Science Festival. It'll be happening end of this month, Thursday through Sunday.
Yep.
You can go on the website to find out more details. I'm going to be doing two things. On Saturday all day, we'll be doing the physics of football at the Wisconsin Institutes for Discovery. We're going to be doing
Physics of football. That sounds.
We're going to be doing some big stuff.
Some big stuff.
Big stuff.
How big?
Oh, you just have to come there and see.
Good tease. You got to
Big
go
stuff.
now.
But on Friday from 4 to 6, I'm part of a demonstration called about sound, and it ends up in a little concert. They're going to have a little musical presentation.
Okay.
But I get to lead it in talking about the physics of sound. So that's what we're going to be talking about today. So sound is a wave. Now, a wave is simply a way to move energy around.
Right.
Okay. Now, usually when we think of waves, we think like ocean waves are going up and down, right? Those are called transverse waves, very common. Sound waves work a little differently. They're called a longitudinal wave. And since we can't see air, we're going to use this slinky here, this spring, to demonstrate. So in a sound wave, you squish the air together and spread it apart. It looks something like this. So you can kind of see those areas where it's squished and then spreads apart.
Right.
Now the distance between those little squished zones, that would be called the wavelength. Okay. Now different tones will have different wavelengths. If we move this down here and put a faster vibration, you can see how those little squished areas are closer together. If we go,
So the wavelength is shorter.
the wavelength is shorter, and we would hear that as a higher frequency or a higher pitched tone. If you do it with a slower frequency, you're going to get a longer wavelength. See how they're more spread out.
And that would be a lower tone.
So that'd be a lower tone, like a bass tone. One of the interesting things about sound, though, about all waves, is that they can add together. And in the case of, that's very important for music. So watch this. They'll travel down, but at that end they bounce back and they start coming back the other direction. When they do that, they create some zones where they add together.
Okay.
And when you see that, you'll see some of these, especially if you watch the strings. Some of the strings won't move very much at all. Some will move a lot. Places where it doesn't move very much at all is called a node.
Okay.
And the places it's moving a lot is called an antinode. It's called a standing wave, and it's very
All right,
important.
Mike, we only got about a minute left here. So let's light some stuff on fire.
This is a demonstration of what happens with that. What I have here is a pipe with some.
Should you be holding that pipe?
Yep,
with the
I have
foot?
an insulated zone here that'll protect my hands. I'm going to make this. There's a screen here. I'm going to make very, very hot. When that hot air starts rising up the tube, it'll start resonating the air in the tube. But only one of those frequencies will bounce back and forth, kind of like what you just saw here.
Okay. Oh. Oh, that's not your television. Mike just did that. Oh, wow. All right, quickly explain how that happened.
Basically, just like you saw here, the sound waves, there's all kinds of sound waves, but only one frequency will start bouncing back and forth, and as it bounces back and forth, it starts reinforcing itself, and so it comes out of this as this one very pure tone, standing waves, and that is the principle for most musical instruments.
All right, Mike, now you do have a couple of, we talked about those two events you have coming up towards the end of this month. Really quick, just break those down for us.
Remember, Wisconsin Science Festival, you can go on to the yscifest.org. You can go, of course, on the Channel 15 website. I'm sure you've got the links to that. We'll be doing the physics of football on Saturday. We'll be doing this musical event Friday from 4 to 6. Both of these events will be at the Wisconsin Institutes for Discovery.
All right, Mike, we appreciate it as always. Thank you very much for coming in here and educating all of us and having some fun with science.